Hello and welcome to another episode of the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. I'm your host, Jared Green, and I've practiced as a geotechnical engineer for over 18 years, and in addition to practicing engineering, I enjoy mentoring young engineers and first-generation college students. I've focused on helping to increase the number of pre-college students that are interested in STEAM majors and fields. By STEAM, that's science, technology, engineering, art, and mathematics. In this episode of the Geotechnical Engineering Podcast, I'll be talking with Dr. Jean-Louis Briaud, who is a distinguished professor and holder of the Buchanan Chair in the Zachry Department of Civil and Environmental Engineering at Texas A&M University, and we'll be talking mostly about unsaturated soil mechanics. Dr. Jean-Louis Briaud is also a distinguished member of the American Society of Civil Engineers and a professional engineer. He has published extensively in geotechnical engineering and is the author of a book entitled Geotechnical Engineering, Unsaturated and Saturated Soils, and is currently the National President for the American Society of Civil Engineers. He's supervised over 50 Ph.D. students and over 90 master's students. He's published about 300 articles and reports in regards to geotechnical engineering. Among other awards, he's received the ASCE Ralph Peck Award from the United States, the CGS Jeffrey Meyerhoff Foundation Engineering Award from Canada, and the Honorable Atayev Medal from Kazakhstan, and is a member of the National Academy of Natural Sciences in Russia. He received his bachelor degree in France and his Ph.D. degree from the University of Ottawa in Canada. And now, let's jump right into our conversation with Dr. Jean-Louis Briaud. Welcome, Dr. Brio, to the Geotechnical Engineering Podcast. Thank you for being on.
My pleasure.
And how are you doing today?
Doing all right.
Okay, excellent. Well, I just introduced you to our listeners, but, in your own words, can you tell us a little bit more about yourself and perhaps some of the subjects you teach at Texas A&M University?
Yeah, I was born and raised, educated in France, and got my bachelor's degree in Paris. Then didn't feel like being cooped up in an engineering office, so decided to see the world. And the best way I could find was to get a master's degree. Went to Canada and got interested in teaching. And they said, well, you have to have a PhD. I said, okay, let's do that. So I got a PhD from the University of Ottawa. And it was a little bit cold in Canada. So I went down to Texas, 1978, and I've been here ever since. I got two children, Patrick and Natalie, and my wife, Janet, all of them wonderful. And I play a fair amount of tennis. I try to play every day.
That's awesome. And I understand you're a little active within ASCE as well, right?
Yes, they put me as president of ASCE, and it's at the same time an honor, a challenge, and a big responsibility. It's a one-year appointment, and you want to do a lot of things in 1 year, but 1 year is relatively short.
Yeah.
So the pressure is on, and you're trying to throw all your energy into this 1 year to try to make a difference. And of course, you work with 150,000 members, 10,000 volunteers, 250 staff, 18 board members. So it's a huge team.
Wow.
But it's a pleasure to be driving the bus.
That is wonderful. I don't know how you can do all that, but I guess it ties back to just having a good team.
Just one point at a time. That's the secret, like in tennis. You can't plan for too many things in advance. Just concentrate on the next point.
That's awesome. And I love that, I had to do my research to get ready to have this conversation. I mean, we've talked before in the past, but I learned some things. I learned that your plight to becoming a civil engineer had something to do with your father.
Oh, yes, definitely. In fact, I did not choose civil engineering. My father told me, "Thou shalt be a civil engineer." And I said, "Yes, sir." And then after that, when I left Paris, and went to Canada. Um, I was surprised that I would get a teaching assistantship.
Okay.
And I said, wait a minute, you're going to be teaching me something, and then you're going to give me some money in addition to this. They said, yes. Oh, I said, this is fantastic. Where do I sign? And I said, by the way, what am I learning? They said, geotechnical engineering. I said, what the heck is that? And so I did not choose civil engineering, and I was bought into geotechnical engineering. That's how it happened. But I've been enjoying it ever since. I can assure you that.
Oh, that is great. That's great. It sounds very transactional, but in the end, it all made sense. And then
Yeah.
I understand, speaking of transaction, I understand that your love from tennis was somewhat, I won't say tied to the piano, but can you tell us a little bit about that?
Oh, well, when I was a student, and by the way, I was a terrible student. When I was in Paris, it's just that I was not that interested in the what I had to learn. I was much more interested in uh, having fun with my friends and discovering life, and so I would play the piano in bars, and so I would play until like 2, 3 o'clock in the morning. So you can imagine the 8 o'clock classes were not my biggest priority. But it worked out in the end. I guess I turned out okay.
Oh, that's great. That's great. Well, that's good for our listeners that, if they might have hit a class and they having some trouble figuring things out, it's good that it works out in the end if you're willing to work hard.
It took me a while, and actually, once I got married, I kind of settled down, and I started to really get interested into geotechnical engineering. So it was a
Mm.
turning moment. So my wife Janet has had a very, very positive influence on me.
Oh, that's great. That's great. And Professor, you're the author of a book, Geotechnical Engineering, Unsaturated and Saturated Soils. How can this book benefit geotechnical engineers as well as college students?
Well, maybe I shouldn't be the one answering that question
just
because
a
it's
just a little biased, right?
a little
But
bit, yeah, a little bit self-serving. But no, I thought it reminds me of a story. I'll share that with you. I have a colleague who worked a lot on pile driving analysis, for deep foundations. And I said, Lee, you need to write a book on this topic because you're so knowledgeable. He said, no, I don't have time. It's just it's past and so on. I said, Lee, I will not let you die until you write that book. He said, good, I'll never write it. So anyway, back to my book. Uh, I felt that it was important that the world of unsaturated soils was developing, the knowledge was accumulating, and yet there was no reasonably simple book that was available so that undergraduate students and people that were not very familiar with this topic could grab and learn from it. So I decided to write it, and got a lot of help from my Ph.D. students. I was president of the International Society at the time, and so there were a lot of weekends and airplane flights where I was working on the book, and you know, it's really helpful for me to use it in my classroom, because before I was saying, oh my goodness, I got to teach this lecture. I've got 2 hours to prepare. Where is this graph? Where is this classification? Where is this? Now it's all in the book. And I say, okay, page 23, figure 17, and that's it. So it simplified my life in teaching for sure.
That's awesome. That's awesome. For somebody, if somebody's not familiar with unsaturated soils, some of our younger listeners, what can you tell them as far as overview?
Wow, this is a big question. We, we, I, so unsaturated soil is a word that's used to describe the soils that are above the water level. When you dig a hole in the ground, you get to a point where you find the water level, and the water below that is going to be in compression, hydrostatic. And then above that level, the water could still be, the soil could be saturated, but the water is in tension because it's being sucked into the pores by the attraction between the water and the silica, primarily the silica component in the soil grains. And this water tension can actually pull up that water to tremendous heights. And then you have another zone above this that is truly unsaturated, where there's air that is in the pores as well as water. So the effect of this water tension in the soils that are above the water level increases the strength of these materials. The big issue is that's good news because when we want to build stuff on the ground, it's good to have something that's stronger. The problem is to make sure that this strength is there during the whole time, at least the whole year, because in the winter it rains, the water level goes up, you could lose this water tension. And so the key question is, can I count on it during the lifetime of the structure that I'm trying to design? So that's a big issue.
And so for somebody that hasn't been exposed to this, I mean, you're stretching what it is you understand from soil mechanics standpoint, because a lot of times we focus a lot on saturated soil mechanics.
Well, that's true. That's true. And, in one sense, Terzaghi, who started our field, had it easy. He started with the saturated soil issue, and there was only 2 phases, and he solved, I'm kidding, obviously, but,
of course.
So he started 1910 or so, and unsaturated soil started maybe in the mid-50s in the UK, and then later in Canada, and then the US. And like any new field, the fundamentals were addressed first, the science, the mechanics, and then there was a second phase where people said, well, this is fine, but how can I use that in everyday practice? And that was the purpose of the book. How can we actually use this advantage in some cases of increased strength, and some of the drawbacks, for example, the swelling, tremendous swelling and shrinking of these materials when they get saturated and unsaturated and so on. How can we use that directly in slope stability, bearing capacity, movements, retaining walls, and so on, so that we can introduce this into practice? And that was the purpose of the book.
Makes a lot of sense. Makes a lot of sense. And, as far as from an engineering standpoint, as far as when we would consider unsaturated soil mechanics, I have to imagine that you would look at it as every project you're thinking about this, right?
Well, yeah, the point, obviously, if you're in the ocean, you don't have this problem. All right. So offshore is out. These folks are working with saturated soil and compression in the water. But in many, certainly in the many parts of even in Canada, you might think, well, when we're up north, there's a lot of rain, but there are some parts of Canada that are pretty dry. And if you find yourself in a climate where it doesn't rain that much, then a lot of the soil, as geotechnical engineers, we deal with the soil in the top, maximum 200 feet from the ground surface. And so if you have water levels that are fairly deep, then suddenly everything you deal with is unsaturated soil. And again, by unsaturated soil, we tend to refer to soils where the water is in tension. So the soil could actually be saturated, but we're applying unsaturated soil mechanics to a soil that's saturated because the water is in tension. Anything above the water table, the water is in tension. And we need to think along those lines because a lot of the problems we face are in the zone above the water table.
Yeah, you're absolutely right. You're absolutely right. And then in some areas, if you have collapsible soils or shrinking soils or swelling soils, if you're not considering this, you can have a problem if a foundation is sitting on a shallow foundation that's sitting on a soil like that.
Oh, I absolutely. And geotechnical engineers, in large part, are very smart gamblers. And the reason I say that is that if you have to predict the behavior, so you're in a building now, Jared, okay? Imagine the building where you are, and below that building is a zone of soil that is fairly large.
Okay.
And then you're going to give me the job of predicting the behavior of that zone of soil your building is going to sit on, and predict the behavior of that soil to plus or minus 30%, let's say, by sampling 0.001% of that material. So I'm taking a very small part of that whole volume,
yeah,
and I've got to make the prediction within plus or minus 30%. I mean, it's scientific gambling. Well, I'm kidding, obviously, you know, we have a lot of, but the point is we need to sample and test a lot more than 0.001% of the material that we have to predict. So very, very tough discipline. Add to this the heterogeneity of the material and this business of unsaturated soil, and this is mighty. So when people tell me, oh, this is not rocket science, I say, no, this is not geotechnical engineering.
You're absolutely right. Well, it's amazing to think of where we are now, and to listen to what you're saying. It sounds like there's a lot more opportunities for research to figure out how to solve these problems better.
Yeah, absolutely. You know, on the one hand, and that brings up the idea of research, and particularly research for young professors, because that's a tremendously important part of what they do. And I wish that somehow industry would work with particularly younger professors to tell them this is what's important to us. Because these young professors, me, for example, in 1978, I wrote stupid proposals because I had no idea what the problems were. But I was told by the department head, Brio, write proposal, get some money, publish the stuff. I said, okay, fine, you know, I'm gonna. And so there is a lot of value to have interaction between people in industry that have the needs, that see the problem on a daily basis,
Yeah.
and the young professors that have some tremendous energy, desire, and motivation to work on these research problems, but they're a little bit lost, like I was 40 years ago. And
Wow.
so we need to get those two groups together, and maybe your podcast can do some of this, you know, interview two people, an industry and a young prof, and see what solution. One idea is to have a website where industry posts what their problems are, so that the young profs can look at that website and say, oh, okay, that's a good idea. I'm going to work on this. And then you connect an industry, an engineer with a young prof, and you have the best of better work.
I love it. It's a great idea. And the reality is that, you know, as engineers, we talk about, you know, we're problem solvers, but you're saying that we have in industry, we have these challenges and we have these problems. We want to figure this out. And you have people that are doing research. And it's like, if the two aren't talking, you can have research that doesn't reflect what we actually need in reality. And that's just a missed opportunity.
Yeah, that's so true. But at the same time, I don't want to minimize the idea of and the whole side of research where people work on weird ideas, you know, wild things. People, you know, when you think of Nobel Prize winners, for example, they didn't really try to solve an industry problem.
Wow.
They just thought of stuff, and in a way they got lucky, you know, because it had a tremendous impact. Yeah. But they worked on something, they were curious, and they were very bright, and they worked, and this thing ballooned, and everybody was using it because it was the underlying basis for a lot of the solutions that we needed. So we don't want to minimize that part of the dreamers, but we also have, I think we're weak on the side of interaction between industry and professors.
Got it. Well, I guess that shows the value of organizations such as American Society of Civil Engineers, and coming to conferences and interacting. The mixing is essential, and it sounds as though staying curious is going to be very important for what we do as
Absolutely.
geotechnical engineers, right?
Well, you look at the evolution of humankind.
Mhm.
Look at transportation, for example. 1,000 years ago, we had horses. 900 years later, 1900, we still had horses. And you fast forward to the year 2000, and now we have cars, trains, airplanes, rockets, and all this has been developed in 100 years.
Fascinating.
Tremendous explosion in technology. And so it's a very exciting time to be in engineering, let alone civil engineering. But at the same time, our number of credit hours has decreased.
Ooh,
When I went to school, it was 150 hours sort of thing.
wow.
Today, we're down to maybe 120, 125 or so. So the science, the knowledge has exploded, but the requirements have decreased. We need to do something. That's why ASCE is trying to have an impact on this issue.
Got it. Got it. So that's a good segue here. So when you think about unsaturated soil mechanics, is this a concept that should be taught at the undergraduate level or graduate level?
I,
And why?
I do think we need to start at the undergraduate level. It's in soils we had three phases: the solids, the water, and the air. That's what it is. And we are in a position, as I said, mid-50s to today. So we're talking about 65 years, and we are in a position to present the basic concepts to undergraduate students.
Yeah.
We cannot continue to say soils are saturated. 40 years ago when I started teaching consolidation, saturated soils, and settlement, when you put load, the students would graduate and they would come back and say, Dr. Brio, you told me they were going down, but the structure I built, it's going up because of the swelling and the high plasticity soils and stuff. So I said, oh my goodness, yes, I better pay attention and start. So I do think we should, now we have to simplify. We have to be
Yeah.
smart enough to make it simple and interesting.
Yeah.
Soils is not exactly the most exciting material you're ever going to do. Very complicated, as I pointed out,
Yeah.
but we have to make it interesting.
Love it. Love it. Yeah. It reminds me of, when I was growing up and, you get to a point in your math classes where you learn about the negatives, and it's like, you've been looking at this timeline all your life, and it's like, it starts at zero and just goes towards the right. And then all of a sudden you find out what goes that way. And, as I grew older, I said, it would have been really nice if when we learned subtraction, we looked at the negatives. Like, why couldn't we talk about it then? Right. Why did we wait until we learned something one way to then learn about something that should have been fundamental,
Yes, and then the saturated soil becomes a special case of the unsaturated soil
Yeah.
approach, and making it attractive. I start all my undergraduate lectures with a case history. So Tower of Pisa, Burj Khalifa, Eiffel Tower, the Kansai Airport in Japan, and that gets the students interested, and then they're ready to listen to some of the more mundane stuff about swords.
That's great. That's great. When you look back, going back, turn the clock a little bit, when you look at the early research for unsaturated soil mechanics, was it something that was looked at as controversial, or that people, did it take a lot of convincing to get people to kind of buy into the concept and notion? Just curious.
Well, the phenomenon by itself was obvious. It was obvious, in other words, that this was something that had to be addressed. It was a natural evolution. But there's no doubt that there was some controversy, and there's still controversy today. Different schools of thoughts, in fact. But as I said, the early days, there were controversies, and papers were published, and discussions were sent because of disagreement. But it was all, from what I can tell, professional disagreement. And that's the best way to arrive. It's like a damping system. At first, you have a lot of vibration, and slowly but surely you come to equilibrium when you build consensus and everybody agrees that the earth rotates around the sun and those kinds of things. Where we don't argue about this anymore.
I like it. I like it. That was a great way to explain consensus, by the way, Professor. That's great. With that, I'm curious, what excites you about geotechnical engineering? When you think about the future of the profession, what excites you?
In my mind, it's two different questions. What excites me about geotechnical engineering is that it's a very diversified field, in the sense that it's as much work in the office as it is work in the field. So if I work in the office with finite element simulations, and after a while I'm bored, I want to breathe some fresh air, so I go out in the field, work behind a drill rig, and after a couple of days, I'm bitten by mosquitoes and I'm sunburned, and I say, okay, it's time to go back to the office. This is a tremendous balance, to what we do, and the material is so complicated that the challenge is definitely there. So unsaturated soil is definitely an exciting area. I do think that another exciting area is to start designing our structures on the basis of risk analysis. 50 years ago, we designed on the basis of a single factor of safety. 25 years ago, we started to use a probability of failure, and that led to the load and resistance factor designs. Today, it doesn't make sense to design a huge bridge like the Golden Gate Bridge to the same probability of failure as a 20-foot culvert. And so we need to put the value of the consequence into our decision process. And that's why a risk-based design, to me, is coming. And it's pretty exciting, because the new generations have to think along those lines. And they're the ones that in those committees and work group are going to develop our standards when it comes, and codes when it comes to that.
Excellent. Thank you so much. That is indeed exciting. So with that, we're going to take a pause for a moment, and then we're going to come back with our career factor safety end segment. Stick around. Hello and welcome back. It's time for our career factor of safety end segment. In geotechnical engineering, like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Dr. Brio. Dr. Brio, you've had an already very successful career. And when you look back at your career, I'd be curious to hear, what have you thought about your career from a standpoint of what it takes to be a good leader? Like, what did you do to give yourself a factor of safety in your career?
Well, it's an interesting question. To me, the factor of safety that I applied was diversification. I tried to, and that's what I really enjoy about being a professor, because as a professor, you have several types of activities. You teach, you do research, you do service, and you get involved with organizations like ASCE or the International Society. And the fact that you have this diversification, if you're really bored with teaching, for example, your research and your service may actually pick up the slack. And if you can't get any money in your research proposals, maybe the teaching is exciting, the young people that you deal with. So I would say my factor of safety would be the diversification. In terms of leadership, I have a set of rules, of the 10 rules for a successful career that maybe I can share with you. Do you have time for this?
Sure, go for it.
So this is a little bit like a David Letterman type of thing, the 10 rules. So you start with rule number 10. So rule number 10, in my mind, and over the years, I've talked to different people, Clyde Baker and many others, and I've come up with those rules. So rule number 10, choose the relentless pursuit of excellence as a way of life. Don't settle for second best. Aim for it. You may not get there, but always aim for excellence. Nice. Number 9, in fact, you mentioned it earlier, be curious. It's amazing how much you learn by being curious. As a civil engineer, take the time to cross the street and go learn what the mechanical engineers are doing. You may come back to civil and look a lot smarter just because you crossed the street. Rule number 8, work hard, but balance your interests. So tough, so tough. You know, you have your work, your family, your health, fitness, your friends, and you're pulled right, left, and center during all those poles of attraction. And the best way to balance, to me, is when one starts to squeak, then it's time to adjust the others, sort of thing. 7, make lots of friends. Public relations, very important. 6, look for solutions and know not who is to blame. Leave the blaming part to the judge and the courtroom and stuff. 5, be firm in your decision, but fair and polite. Nice. Listen, and then once you have data, make your decision, be clear, be firm, and go forward. 4, treat others as you wish to be treated. I think that's pretty obvious. 3, communication is the best way to solve problems. I believe that talking with people is the best way to have a better understanding. 2, surround yourself with smart people. Don't be afraid. If you're starting your company, for example, don't be afraid to hire people that are smarter than you are, because in the end, they're going to make you look good. And then rule number 1 in my mind is go after your dreams with vision and perseverance. If something is important to you, if you're dreaming about something, go for it. That'd be my few lessons for a good career.
Dr. Brio, that was awesome. That was awesome. Well, thank you so much for coming on, and thank you for sharing all these great insights with us. I can imagine our listeners really, really are going to enjoy this. If our listeners wanted to reach out to you, what's the best way for them to find you? Email you want to share, or social media outlet?
No, email is fine. So brio@tamu.edu. Just Google my name and you'll find my email. I'll do my best to respond. Excellent. It's in final comment.
Yes.
When I was young, I really cared about being successful, and to me it meant awards, recognition, publication, and stuff. And slowly, as I grew older, there was a transition in my goal, and now I wish to help people. That's what's become very helpful to me, very important to me. And so I don't mind having hundreds of emails. I'll take the time, may take a couple of weekends, but brio@tamu.edu. Everybody welcome.
Excellent. Thank you so much for coming on. All right.
You're welcome.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 20, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.